So we're moving on to lesson 7.5 today. We have a new learning goal. So we're not factoring trinomials for a while. Doesn't mean they're going away. It says I can factor the difference of two squares. What kind of polynomials have two terms? What are they called? Binomials. So we're going to be factoring binomials today. And we're going to look to see if they are a special binomial. And you're going to find this to be, you're going to be like, whew, a little reprieve here. Okay? Now, what's going to be the trickiest about all of this is you knowing your perfect squares. So let's talk about perfect squares. What's a perfect square? What am I talking about when I say perfect square? What numbers are perfect squares? They're whole numbers, and is 2 a perfect square?
Yes.
Why? Because it's so nice.
Because nothing
like
can
it.
go into 2 to equal 2.
Nothing can go into 2 to equal 2, so that makes it a perfect square?
Like,
Okay.
Something that can be divided by itself that won't give you a decimal is a perfect square.
When something is divided by itself, what does it have to give you?
1.
1? So
it's just like
any number is divisible by 1, so that means any number is a perfect square?
No, it's just like it's like 4. Like you take 2 times 2 to equal 4.
So 4 is a perfect square because when you take 2, a number times itself, you get 4. So remember, what square means
A right angle.
rectangle with, what's so special about the rectangle
90
that's a
degrees.
square? Well, if it's a rectangle, it has to have 90 degrees. What makes it a special rectangle, a square? All the sides are equal. So in other words, if you have a square, when you find the area of a square, you take a number times itself, don't you? It's a perfect square. So 2 times 2 that square would have an area of 4. How about 1? Is 1 a perfect square?
Yes.
Yeah, it's 1 times 1 equals
Because 1 times 1, if you had a square with side lengths of 1, 1 times 1 is 1. How about 2? Is 2 a perfect square?
no.
Yes.
Can you make a square that has whole number side lengths that would give you an area of 2?
Because only 1 times 2 equals 2.
Yeah, the only thing that equals 2 is 1 times 2, and that isn't a number times itself. So 2 is not a perfect square. How about 3?
No.
No. Okay, we've already decided 1 is. We've decided 2 and 3 are not. We've decided 4 is. How about 5?
No.
6.
Mostly the even numbers.
Oh, mostly the even numbers. Well, 2 wasn't, though. And 2 is an even number.
6 isn't.
Well, 2 is
6
like
isn't, and
first
it's an
equal.
even number. What is the next perfect square after 4? 8?
9.
No.
9.
Why is it 9?
Because
Because
3
9
times 3.
Because 3 times 3 is 9. Oh, so 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. What's the next perfect square?
8.
16.
16, because 4 times 4 is 16. What's the next perfect square?
25.
25, because
5 times
5 times 5 is 25. Oh, you better get these memorized, it sounds like.
36.
All you have to do is start with the whole number 1, take it times itself, you have a perfect square. And then keep going up and say 2 times 2, 3 times 3, 4 times 4, 5 times 5. So who thinks they can continue on with the square list, perfect square list for us? You can just recite for a while. No, what is it? After 25, the next one is?
36.
Next,
49.
next,
64.
next,
81.
next,
100.
next,
144. No, 121.
next,
144.
next.
I don't know what comes after that.
Good job. You made it all the way up through what? 144, which is what?
12.
12 times 12. Anybody think they know the next one? Here's what I would recommend, that you learn these perfect squares all the way through 15 times 15. So let's figure out what is 13 times 13. Let's learn it. 169. 14 times 14. 196. 15 times 15. 225. Okay, you're going to learn these, aren't you? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. You should be able able to state them, okay? If you need to write them at the top of your paper for right now, then write them at the top of your paper. Let's go. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Now when it gets harder. 121, 121, 144, 169. Have the 6 and the 9 trade places. 196. And last
225.
225. Okay, those are going to be useful pieces of information because if I say no calculator, you want to know those. Okay, so today what we're going to focus on is factoring special binomial. And here's when a binomial is special. Okay, when a binomial has subtraction. That's what I want. When the binomial has subtraction, and that's important, there has to be subtraction going on in this binomial between these two terms. And both terms are perfect squares. You know, we just listed the first 15 of them. It is called the difference meaning the answer you get when you do a subtraction problem. It's telling you there's a subtraction going on of 2 because a binomial has 2 terms. And both of these terms are going to be perfect squares, so we're going to say this is a special binomial called the difference of 2 squares. So when I ask you that question, or you ask yourself that question, that's what you say. Is this the difference of 2 squares? Is it a binomial that has subtraction, that both terms are perfect squares? Now, variable terms can also be squares. They can also be perfect squares, such as x squared. Why is x squared a square, a perfect square?
X times itself twice is that number.
Yeah, x times x is x squared. Give me another example of a variable term that you think would be considered a perfect square or a square.
X to the 4th.
X to the 4th power. Why x to the 4th?
Is x times itself 4 times, or x times itself 4 times.
No, square.
Oh,
Something
so
times itself 2 times. So what times itself 2 times gives you x to the 4th?
x to the 2nd times x to the 2nd.
Yeah, x to the 2nd times x to the 2nd is x to the 4th. So that's a square. Okay? So examples. X squared minus 9. It's a binomial. There are 2 terms, x squared and 9. It has subtraction. And both terms are perfect squares. X squared is a perfect square, and 9 is a perfect square. 4x squared minus 25. It's a binomial, 2 terms. 4x squared is a perfect square. Are you convinced that it's a perfect square? What would be the square root of 4x squared? What times itself would be 4x squared? 2x. Yeah, 2x. 2x times 2x. 2 times 2 is 4. X times x is x squared. So it's a perfect square. There's subtraction. 25 is a perfect square. That's one of those difference of 2 squares. Somebody give us another one. Difference of 2 squares.
16x squared minus 81.
16x squared minus 81. Let's test them out. Is he right? Is it a binomial
Yes.
with subtraction?
Yes.
Perfect squares at the front, perfect square at the back. Both terms are perfect squares. What's the square root of 16x squared?
4x.
4x. What's the square root of 81? Sounds like it is. So here's what we're going to do. When we have the difference of 2 squares, it's going to be this easy. To factor them, find the square root. Remember I just said to you, what's the square root of 16x squared? What's the square root of 81? Find the square root of each term. Find that number or that term that times itself will get you what you're finding the square root of. Each of your factors now, so basically what's going to happen is we're going to have binomial factors for this binomial. It's going to look kind of weird, but we're going to actually have a binomial times another binomial. That would be the factor name for the binomial that we started with. Each factor will begin with the square root of the first term. So each factor, once we find the square root of the first term, we're going to say, oh, each factor is going to start with that and end with the square root of the second term, the other term. Well, the only way to not have a middle term when you multiply binomials, think of FOIL now. I was all thinking about FOIL for a moment. FOIL. When you have FOIL, you have an F step, an O step, an I step, and an L step. And typically, what can happen when we are foiling? Typically, what can happen? Aurora?
The O and the I can be combined.
Yeah, the O and the I can be combined. And they become then a term together. And so then we have the F step and the L step. They're each a term. And then we have the O and the I step that came together and they became a term. And now we have a trinomial result, don't we? Well, what's got to happen when you're foiling for there just to be a binomial result?
Yeah.
What has to happen in that O and that I step? Aurora?
If they cancel each other.
They got to cancel each other out. They got to be opposites of each other. They got to combine to be nothing, to be zero. So if we have addition in one of our factors and we have subtraction in the other, guess what happens? The O and the I step become opposites in this situation, and we don't have that third term. So, here's how we show work with these. We look at the problem and we say, first of all, is it a binomial? This is all like thoughts in your head. Is x squared minus 9, number 1, is that a binomial?
Yes.
Okay, next thing you say to yourself, is there subtraction?
Yes.
Okay, next thing you do is you say, can I take the square root of x squared? Is it a perfect square?
Yes.
Okay, so we would show this work. The square root of x squared is
X.
x. And then we would show taking the square root of the other term in our binomial, which is 9, the square root of 9. Can we take the square root of 9?
Yes.
What do we get?
3.
3. Yes, Michaela?
Would you make the 9 negative at all since it's...
Nope, we don't, because the subtraction takes care of that. We just leave it as subtraction. We don't let that 9 take on the negative. Okay? So we say we have a perfect square, subtract another perfect square. So we don't make that a negative 9. Good question. Okay, then it says, each factor will start with the square root of the first term. Each factor will start with the square root of the first term. Each factor will end with the square root of the second term.
One factor will have addition, one will have subtraction.
One will have addition, the other will have subtraction. There's our answer, right there. There's the factor name for x squared minus 9. Because what is our b value in x squared minus 9? What's our b value? So, what is a in this? What's a in x squared minus 9? A is 1. B is? 0. There aren't any x's. It must have been 0. 0 times x, there are no x's. And c is negative 9, really, right? So here's what happens. When we FOIL this, what would the O and the I steps look like when you FOIL this? O step would be x times negative 3, which is negative 3x. The I step would be 3 times x, which is,
3.
what's negative 3x plus 3x? 0x. They're gone, aren't they? So the O and the I step become opposites. And then what's 3 times negative 3? Negative 9. There's that minus 9. Okay? So when we have these special binomials, we can always count on that when you get the factor name for it, the O and the I step would combine to be opposites, so they're no longer there. But yet, we have two binomial factors, notice, okay? Why don't you go ahead and try number 2? So what kind of work did I show in number 1? And what kind of work do you think you better show to help you factor x squared minus 64? Isn't it binomial?
Yes.
Is it subtraction? And Faith, the factor name is what?
X plus 8. X minus 8.
Because the square root of x squared is x. The square root of 64 is 8. Both factors start with x. Both factors end with 8. One has addition, the other has subtraction. Faith is right. How many do you agree with? I'm not sure she's right. You're definitely wrong. Agree with her, right? Okay. So that's what you do with these. How easy is that?
Okay.
Pretty easy, right? Okay. Let's look at the ones though where they don't just start with x squared. Like number 3, it starts with 4x squared, ends with 25. It only has the 2 terms. It does have subtraction. Is this a special binomial? Yes, it's a special binomial. So we take the square root of 4x squared. What is that? 2x. Because 2 times 2 is 4. X times x is x squared, right? And the square root of 25 is 5. So Clarion, the factors would look like, not that. What? You don't know? Okay, you're gonna pass. Okay, Abby?
2x plus 5. And 2x minus
Does it matter which one is first?
No.
Could it be 2x minus 5 times 2x plus 5? Yeah. Go ahead, you do the last one then, on this side. What is 9x squared minus 16? What's its factor name? And trust me, it is going to be really important that we keep learning how to factor because we're going to use factoring to help us solve quadratic equations coming up in chapter 8. Calvin, can you tell me what the work looks like, please?
9x to the second. And then whatever that deal is that goes around it.
Square root.
Yeah, square.
Okay. Called a radical sign, and it is said the square root of. Yeah. Okay.
And then equals 3x.
Okay.
16 with the radical sign.
So the square root of 16. Okay.
Yeah, equals 4.
Okay. And the factor name for this is what, Devante?
The 3x plus 4 times 3x minus 4.
Do we all agree? Yes. Okay, we got this, don't we? Anybody got questions? Okay, then let's go talk about something that I present you with on the back. Number 5. Is this a binomial? Yeah. Is it a subtraction? Yeah. Does it start with a perfect square?
Yes.
Can you take square root of 1?
Yeah.
Yeah. Okay. What is it?
1.
1. Can you take the square root of 36x squared?
Yes.
It is
6x.
6x. So then what would the factor name be? Cody?
1 plus 6x and 1 minus 6x. Or you could have 6x plus 1 and negative 6x plus 1.
So now we're hearing kind of like we got some options here, it sounds like. We could write 1 plus 6x, Cody says, 1 minus 6x, Or he says, if you want to write it like this, you could write 1 plus 6x times 1 plus a negative, or no, it was like this, 6x plus 1, negative 6x plus 1. And then some of you are like, well, wait a minute, can't we just write it like this, 6x plus 1 times 6x minus 1?
No.
So is that a third option?
Wouldn't it like not matter as long as your end result that when you FOIL it, it's going to be 1 minus 36x?
You are so right. No, it's got to come back to this, doesn't it? So no matter what way you write it, it better come back to that. So let's explore that one. We'll just do it. You don't have to do it on your paper there. I'll just do it here, and we'll watch and see what happens. So those of you who said, well, can't you just do it like this? Because you know what? 6x seems more important than 1, so let it be first. Is this what I was hearing? Some of you think we should be able to do this?
That's what Cody said.
No. This is what Cody said. Cody said you could write it like this. Am I right, Cody?
Yes.
And then one of his other options was this. So we got this or that or that. But Noah said, and Noah's a pretty wise man, he said that it has to, no matter which way you write it, it has to multiply back to be 1 minus 36x squared. Are you convinced that all 3 of those ways would do that? Now, I don't want you to mess around with the O and the I step, because you know what? When you have terms that always start with the same thing and end with the same thing, and one has addition and one has subtraction, the O and the I step are going to always cancel each other out. So in this case, they both start with the same, end with the same, one has addition, one has subtraction. So we can just do the F and the L step. 1 times 1? 1. 6x times negative 6x. Negative 36x squared. Does that one work? Yes. Okay, how about this one? They both start with 6x, they both end with 1. One's got addition, the other's got subtraction. Let's just do the F and the L step. 6x times 6x. 36x squared. 1 times negative 1. Negative 1. Is this the same as 1 minus 36x squared? No. This is 36x squared minus 1. So can we do that one? No, we can't. So now the question is, do we think that we can do this one of Cody's? They don't both start with the same thing, but they do end with the same thing, but they both have addition, so now we've really got to throw this whole thing out.
Both need words x's.
But
Well,
worse.
yeah.
Can I do that description first again?
Sure. So they don't both start with the same thing. One is a positive 6x and the other one's a negative 6x. So I'm sorry, I disagree that they start with the same thing. And I disagree that they both, one has addition and the other has subtraction, because they both have addition, don't they?
Or also known as 1 minus 36x to the second.
Can't change it like that.
Addition is not the key subtraction.
Oh, so maybe you should show them that just having them trade places as addition first, and then you can clean it up like you did. Maybe then they'll be
Since
good.
it's addition, you can have 1 switch and a 36
So
switch.
just write it that way, 1 plus negative 36x squared, right? Now they're just trading places because addition allows that. When you clean up 1 plus negative 36x squared, is that 1 minus 36x squared? Huh, seems to me it looks like Cody's right. So what did Cody do?
You put a negative.
So what did he have, what did he actually do that's different from this to that?
You switch them.
He had them trade places, didn't he? He had the terms trade places. So to let them trade places in this one, that's no big deal because it's addition. They can just trade, just like they did. 1 and 6x can trade places and it can become 6x plus 1. Huh. How about these guys? Can they just trade places when it's subtraction? Not until you change it to add the opposite. Now they can trade places, and that would be negative 6x plus 1. Huh, that's all he did. He just renamed them. So, gotta know what we're doing though, don't we? So there are a couple of different ways to write this factored name, but there's an incorrect way also. Okay? So anybody have any questions? Okay, so much for making it easy, huh? Okay, let's do that. Do that one on your own now. Number 6. 6x squared minus 49 is a binomial? Yes. Does it have subtraction?
Yes.
Okay, next question. Next question.
It is not a perfect square.
Can you take the square root of 6x squared?
No,
Why not?
because it's
Because nothing times itself equals 6.
Yeah, nothing times itself equals 6. There is something times itself that gives you the x squared part, but nothing times itself gives you 6. In other words, 6 is not a perfect square, is it? So, can this one be factored using this,
No.
quick little method that we just had? No. You can't do this. So we would say not factorable, at least today. Okay, now, I have a warning for you. Don't be fooled into thinking you can do the same thing with the sum of 2 squares. What does sum mean? There's addition going on. So if you have a binomial, but they both pieces of that binomial are perfect squares, but it doesn't have subtraction, it has addition instead. Do not be fooled into thinking that this is a special binomial. Let's see why. Okay? Here's what happens. I see this all the time, even when I taught college algebra up at the college. They thought you could factor x squared plus 4 into, they said, well, you know what, since it's got addition, I'll just give both of them additions. X plus 2 times x plus 2. What happens when we FOIL x? Go ahead, FOIL that out. What happens when you FOIL x plus 2 times x plus 2? I didn't get x squared plus 4, did you? I got x squared plus 4x plus 4. Is that another name for x squared plus 4? No. They didn't cancel each other out, did they? Well, then you're like, okay, well, fine. I know that when you take a negative times a negative, you also get a positive. So maybe x minus 2 times x minus 2 works. Go ahead and try that one. Does x minus 2 change to add the opposite? Does that one FOIL out to be x squared plus 4 then? Because negative 2 times negative 2 is positive 4. Did it work? You do the middle term again this time, don't you? So you get your x squared at the beginning, you get your 4 at the end, and it's plus 4 at the end, but you have that extra term in there that you can't have. We started with a binomial, we can't end with a trinomial, can we? So do you think x squared plus 4 is factorable? No. Big, fat, no. Don't try and convince you or anybody else that x squared plus 4 is factorable just because it starts with a perfect square and it ends with a perfect square and it's a binomial. What's missing?
The
One of them
subtraction.
has to be different. So,
And
one
using
has to
the
be
subtraction.
positive, one has to be negative.
Yeah, it's kind of like, so we need a subtraction, don't we? Not an addition, we need a subtraction. It is not the sum of two squares that makes a special product. What kind of special product do we call it? The difference of two squares. You have the difference of two squares. Okay, think you're ready to do this on your own? So back here, the majority of what we're doing at the back is exploring what's going to happen when I come upon a binomial that has addition in it. Can I do what I was doing with all those other ones? No, I cannot. Okay,